Hi everyone. So in this particular week, what we are going to do is to use some of the survey data that we have downloaded already, and we will try to do some estimation and inference based on those data sets. So to start with, in here I have already downloaded 3 cycles of the data: CCHS 1.1, CCHS 2.1, CCHS 3.1, and the instructions of how to download them were discussed in the previous labs. You can check the size of these 3 different cycles. You can see the dimensions to get them. Before doing any analysis, first we need to identify which of the variables we need to incorporate in our analysis, and by subsetting I mean that subsetting the number of variables. And before that, I think it is a very good idea to get familiar with some of the coding and type of variables you have in your CCHS data. Say for example, it could be a coded data, it could be a derived variable, it could be a flag variable. Generally these derived variables are derived or calculated based on other variables that exist in the data. So in our dataset, what we are doing here is we are trying to get the variables that are associated with a particular research question. So for example, in our case, we have whether a patient has heart or subject has heart disease or not is our outcome. Whether a patient has rheumatoid arthritis or not is the exposure variable, and that variable can be created using these 2 variables. All of these other variables that you are seeing are basically the covariate information, and the last variable is the survey weight. So basically this dataset is coming from the CCHS dataset, and in the public format of the data they do not publish the strata or cluster information, so we have to work with only the weights here. So since we are using 3 different cycles of the data, these variable concepts have slightly different names in all of these different strata, different cycles. Say for example, if you go to the data dictionary and try to find out in the CCHS this, you will see that this variable represents the concept has heart disease or not, and this also gives you some additional information when you are looking at the data dictionary. So it can give you all of the different responses, what were the codes, how many samples responded, and if you consider the weighting, then how many subjects in the total population gets translated from this sample. One of the important things to notice here is the universe, the who responded to this question, and that part I will get back to a bit later. So you see that whether it has heart disease or not, there were a couple of arthritis related questions in that particular cycle. Say for example, if I'm looking for arthritis, there are a couple of variables that may be of interest. One of those variables is whether it has arthritis or rheumatoid arthritis, and that variable's name is CCCE051, CCCE underscore 051, and again here the universe is all respondents, right? Alright, similarly, if you go to the other data dictionary, so this is from CCHS 3.1. If you go to CCHS 2.1, you will see there is another variable that has this concept, but this time the variable name is slightly different. instead of CCCE I have now CCCC in here, underscore 051. And similarly, if I go to the CCHS1, now CCCA underscore 051. See, CCCA underscore 051. So just by looking at the dataset, I try to identify whether I have my outcome variable, whether I have variables to create my exposure variable, and whether I have some of the basic covariates for this analysis. And I collect all of these names in a table. One of the very important aspect of this is the universe. Say for example, when I was looking at the universe of this variable, this variable's universe is, say for example, for CCH is 3.1, universe is people who responded to question. This is another question and this is another question, but if you go back to the original question, sorry, copy selection, see, the original question was this and the universe was all respondents, right? And then if you go back to the another question that was related to this universe, again all respondent. So this is not much of a concern because everybody responded. Similarly, if you look at this variable, length of time in Canada since immigration, the universe is this. So if you look at this variable, say for example, if you look for this variable in the data dictionary for 3.1, you will see this variable is used in the universe, but this variable does not really exist in this data dictionary. That means that was a variable that was in the master data file but not available in the public format of the dataset, and that can happen. But generally speaking, it's not really telling you whether there was any restriction or not in those particular variables. Look at the BMI variable, and it says all respondent excluding the pregnant woman, and this variable does not exist in the public format of the data. So not really much to tell you about who got excluded. So from just by looking at the data, you do not really know who was asked that question. So this particular variable, self-perceived stress, if you look at the original variable, you will see it has universe is respondents aged 15 or over. That means anybody who was below 15 years of age. So for example, for this CCHS dataset, 12-year-olds were allowed to respond to some of the questions, but for this particular question only 15 plus respondents were allowed to answer this question. So if you include this variable, you need to make sure that nobody below this 15 years of age are included. But if you are thinking that you will impute these variables somehow later on, that's a different story. Again, when you are looking at the COPD variable, you see the respondent age 30 or over. So nobody below 30 were asked this question. So again, if you include this variable, you probably need to think about whether you want to restrict your age group from 30 plus to make sure that this variable is similar to the other variables universe, or you can think about imputation. But my understanding is that if you try to impute that many values, you might not get very good estimates in imputation. Alright, most important variable we have collected is this one. You can see that in this variable, the universe is respondent to this, and that gives you the information. Let me show you how the universe is working here. So this is the variable. It says that whoever answered this particular question. Okay, so what is this question? So this question is optional module fruit and vegetable. So that means what? If you choose this variable, you are at the risk that not all province ask this question. Some of the provinces collected this response, but some of the provinces did not. So you again need to make a decision about what you want to do about this. And if you go to the CCHS 3.1 guide in page 66, you will see that fruit vegetable was collected only from PEI, Ontario, Alberta, and British Columbia. For rest of the provinces, this fruit and vegetable variable was not collected. So potentially we have identified 3 variables that are problematic: self-perceived stress 15 years plus, COPD 30 year plus, and this fruit and vegetable consumption variable that was asked only in 3 provinces, in four of these provinces, but rest of the provinces did not choose to opt for this optional cycle. All right, so we let's just keep these variables in mind, but we will try to include all of these variables for now to see what happens. So we have all of these variables from cycle 1, 2, and 3. Let us just include all of these variables from cycle 1 into one dataset and restrict the dataset to only these variables. So there were many other variables. In total, we had 614 variables in cycle 1. Cycle 2 had 10,000 variable, and in cycle 3 we had 1200 plus variables. So let us just restrict our cycle 1 from 614 to only these 23 variables. Similarly, we do the same for cycle 2. Remember, the cycle 2 variables name was slightly different. See here, for cycle 1 it was A, cycle 2 it was C, cycle 3 it was E. So we need to include those variables separately for cycle 2 and restrict our dataset to only those 23 variables. We do the same for cycle 3. And then these are names that are very hard to remember. What is the name of this variable? And every time you need to come back to this code book to find out what was this variable representing, right? So to avoid that, one thing you can do is, since you kept all of the variables in same order in the CCHS 1, 2, and 3, let us just use the same names, the concepts. Say for example, cardiovascular disease, arthritis kind, age, sex, marriage, race, immigration. So these are much more readable names, and it will be easier for you to remember as well. So rename them to these readable names, and then use those names to replace all of the previous names that you have used in the previous 3 datasets. And then you can try to check whether in the first data, arthritis variable was giving you the right result that you were expecting. So in CCHS 1, 2, and 3, you can get the same type of responses in different frequency, of course. Also, this is very important for later. You want to create a variable that can identify from which cycle this data is coming from. So for now it is very easy because we have separate datasets. So CCHS 1.1, 2.1, and 3.1 was in 3 different datasets, but we are going to combine this dataset later. So before we combine, it is very important that you give some identifying information. So for example, give the cycle name so that later on you can identify from which cycle a particular respondent is coming from. Alright, we are just using rbind command, and see, because we have the same names it is now possible to combine all of the dataset into one dataset, right? And also look at the sampling variables. So the sampling variable goes from 1 to 7,000. That means there was at least one person in the dataset who was representing more than 7,000 persons in the population. That means that maybe that person was from a rare population or subpopulation. Alright, we need to think about creating the exposure variable. In terms of the exposure variable, there are two variables here. So we are particularly interested about whether a person has osteoarthritis or not. And not applicable means what? Not applicable means that at first they were asked whether you have arthritis or not, and then they were asked if you have arthritis, then what kind of arthritis, right? So whoever is in the not applicable group is basically the group that answered no to the variable whether you have arthritis or not. So this is the variable that did not have arthritis, and everybody else said in the first question that they either had arthritis, and then they have subcategorized whether they have rheumatoid arthritis, osteoarthritis, and other kind of arthritis and things like that. All right, so now that we know this, it is very easy for us to only record the variable in such a way that osteoarthritis is osteoarthritis, not applicable is not applicable, because these are basically the no, I do not have arthritis response, and everything else that you have, all of the refusal, not stated, and don't know, put them in the else category. So everybody else will be assigned a missing value, and you now have the number of who do not have arthritis and who have osteoarthritis. I do not want to include other kind of arthritis in this analysis because that might confound the relationship that I'm interested in. Alright, now this is just a matter of recoding. I'm just naming the osteoarthritis and giving it a small name OA, and whoever was not applicable, I'm giving them the name control, or they did not have any arthritis at all. Alright, so in terms of outcome, this is much easier. I directly have a variable that gives me information of whether they have arthritis, cardiovascular disease or not, yes or no. Everything else I need to assign a not available value or missing value, right? And let me just rename yes to an event and no to a no event, because this cardiovascular disease is the outcome variable in our case. Similarly, we work with age group. So there are many different age groups. I just want to combine the age groups to some smaller number of categories. And then I'm working with the sex group. There was only male and female group there. No other information was incorporated. Marital status variable was this. Let's just simplify it to single, not single, and missing. Race, there was a couple of different race variables. Let us just convert them to white and non-white, and everything else is missing. Immigration category, recent, whether they are not recent, whether they are not immigrant at all. Education category, I record them. Income category, I record them. BMI category, I simply record them into this from a continuous variable. This is a not recommended practice, that if you have a continuous variable, for the statistical purposes, having a continuous variable in your regression model is beneficial, but sometimes for interpretation purposes we do this kind of categorizations at the expense of the statistical benefits. So physical activity, I again record them, whether they had access to doctor, record them, whether they had stress, I record them, to not too stressed. Smoking, there are many categories, I record them. Alcohol, I record them. Fruit and vegetable consumption, this is again a continuous variable, and for the purposes of interpretation I am making it categorical, which is again not the best idea in the statistical sense. Hypertension, I record them COPD, I record them diabetes, I record them yes no, north and south, which provinces are north and which provinces are in south. I am recategorizing them in here to the south, all of the south of Canadian provinces and north of Canadian provinces. There are a couple of things that you should know. So for example, if you go to the data dictionary, you will see the names are written very nicely, but if you print out the table of that variable, you will see the names are slightly different. See this Prince Edward Island, but here it is writing PEI. There is only Quebec here, but in here you can see one Quebec here and there should be another Quebec here. See the slight difference in this. So you need to be very careful about looking at the data. Sometimes the data's labels do not match with the labels that are provided in the data dictionary, right? And then you need to do some dimension testing as well. There were 23 variables originally, but we have included a ID variable, so now we have 24 variables. Let's just save this dataset for the next part of the lab.